Hi boys and girls, this is Mrs. Twisdale here for lesson 3.4, comparing and ordering rational numbers. Your objective today is I can compare and order rational numbers. For comparing comparing is greater than, less than, or equal to, and then ordering is greatest to least, or the other way around. So that's what we're working with rational numbers. Let's go. Okay, so I'm working out of the Go Math book, so you can work in your notebook or include the math book pages. Whatever works best for you. You'll find them in the Go Math book if you want to look there. Just so that I have the table and the number lines. They're just too hard to draw on the iPad, especially when I don't have a stylus. So, let's go ahead and get started on the first example. This table shows the average December temperatures in 5 U.S. cities. So we're looking at the cities. Here's the average temperature. When was it? It was in December. Which city has the greater average December temperature? Indianapolis or Boise? So we're looking which one is the greater average. So I'm going to show you two ways to do this. I just held up two fingers and realized you guys couldn't see me. The first one is I'm going to use a number line. So we're going to graph the temperature for Indianapolis first, which was less than 3.3. It's negative 0.6. So negative 0.6 is going to be right about here. Okay, is that right? Let's see, maybe a little further. 0.246, right there. So hard to write that small. Okay, right there. And then Boise would be a negative 1. Let's go ahead and mark negative 1, which would be there. So as you move to the right on a number line, the numbers become greater. So negative 0.6 is to the right of negative 1. So the city whose temperature is further to the right is warmer. And so when we're looking at which city has the greater average, it would be the one that we colored in black, which was Indianapolis. Now let me go ahead and show you another way. Another way you can do this is to use place value to compare the decimals. So if you were using place value, you would write the temperature. Indianapolis has 0.6. It's negative 0.6. Let's see. And Boise has negative 1.0. And then you would compare the digits. 0 is greater than negative 1. And negative 0.6 is greater than, negative 0.6 is greater than negative 1. Oh, Felicity, hold on. So, negative 0.6 is greater than negative 1, which means negative 0.6 degrees Celsius is warmer than negative 1 degree Celsius. So, Indianapolis, it's terrible handwriting, has a greater average temperature, December temperature, than Boise. I don't know why that got cut off, but there it is. So I just showed you two different ways to solve the same problem. The first one we used a number line. The second one we used place value. I want you to think about which way you prefer, and you can do whichever way you want, but there are multiple strategies to solve a problem. Okay, so let's go ahead and answer this next example. So we're talking about the elevation of objects found in a dig site are recorded in the table. Which object was found at a lower elevation? So the fossil of the fish, the fossil of the shell, or the fossil of the fish. So we're looking here over at our table. The fossil of the shell was 3.5. The fossil of the fish, negative 3.5, and negative 3 1/4. tiny little font there. So we're seeing which one was found lower. So let's go ahead and do the first way. One way is to use a number line. We're going to graph the elevations for the fossil of the shell and the fossil of the fish. So the shell would be -3 and 1/2. So we go down to -3 and then a little bit further to -1/2. And that is going to be the shell. I'm going to switch colors here. And the fish was -3 and 1/4. So I'm going to go down to -3 and a fourth of the way down would be the fish. Now if I imagine 0 is where the ground is and they're digging down this way, the one that was found further down would be the shell. And we could put in here, as you move down on a vertical number line, the numbers become less. -3.5 is lower than -3 1/4 on the number line. So the shell was found further down. Another way we could have done this is we could use common denominators to compare the fractions. So -3.5 is also -3. If we used a fourth, it would be -3 and 2/4 and -3 and 1/4. So since the whole numbers are the same, you only need to compare the fractions. If the number is negative, include a negative sign with the fraction, is what it's saying to me. Hold on, let me read this. -2/4 is less than -1/4, so -3.5 is less than -3 and 1/4. So the fossil of the shell was found at a lower elevation than the fossil of the fish. Okay, so that's your next example. And I really like this, for me personally, and it's always your opinion. This way was hard for me. I prefer this way. But it is always your opinion. Remember, with negative numbers, you have to think the bigger the number, the smaller it is. So it's kind of backwards. Okay, so let's do some level 2 problems. Here's my example problem, and then you're going to do the 2 try it. So for example, -1/2, is that greater than or less than -3/7? I can draw a quick number line here. Put 0, 1, 2. Sorry, this would be negative. -1, -2. Here's +1, +2, and +3 since it fits. So -1/2, well, -3/7. I'm thinking, where would that go? I'll go right. -1/2 would be right here. Okay. And -3/7 would actually be, because -3.57 would be the -1/2. So it would be right here. Is that right? And -3/7 is normally smaller, so it would be bigger. Oh, did I do that wrong? I did that backwards, sorry. It is so backwards. It takes a second for my brain to flip it around and put it the other direction. Because normally 3/7 is smaller, but because it's negative, it's bigger. So go ahead and try these 2 try it problems on your own. Okay, so to check your work, they're both negative, which we always want to check for first. -18 and -23. -18 is actually going to be larger because -23 is further to the left. And to check this one, I'm going to look at just the whole numbers. -3. Oh, sorry. Let's do the laser instead. -3 and -4. Well, -3 is going to be closer to 0, so it is going to be larger because it is further to the right. Okay. And that is your try it problems. Let's see. I think I'm Okay, so now we're going to do some ordering because that was also part of our objective. So I'll do the example and then you can do the try it. So one thing I like to remember is that if it's positive, it's always going to be bigger than negative. Always, always. So I look at my first three numbers, and I know that 1.9 is going to be the largest because the other two are negative. So I'm going to put that as my biggest number first, and then I'll compare the other two numbers. And then I have negative 7.6 and negative 2.4. Well, I know that the next on the number line would be negative 2.4 because negative 2 is bigger than negative 7.6 because remember, as you're going negative, those numbers, the bigger they are, the further away from 0 they are, and the smaller they are. Okay, go ahead and try your try it problems. So you guys kind of got some tricky ones. Number 12, they're all negative first of all, and so it makes it a little tricky. So I'm going to draw a little number line here. And it looks like all of them are between 0 and 1. Okay? And I'm going to split this up into tenths. 1, negative 1, 10, 2, 3, 4, 5, 6, 7, 8, 9. And that would be 10. So halfway would be right here. So this would be negative 1/2. Okay? Negative 3/4 is going to be right about here, right about there. Negative 3/4. And if I split this into 2/5, so 2/5 is the same as 4/10. And since it's already split into tenths, I can go 1, 2, 3, 4/10, which is also 2/5. And so now I can go ahead and see which one's the biggest, and I'm just going to go straight from 0. Coming across, here's my largest, second largest, and smallest. So now I just need to put those on here. Negative 2/5, negative 1/2, and negative 3/4. Okay, let's check the work on the next one. So I can automatically see that 3 is going to be my largest because it's the only positive. And then I know that negative 6 is smaller than negative 3, so I don't even have to worry about those fractions. I can't even see what those are. I think it's 4/8 maybe. And then negative 3 and 2/3. Okay, one more problem. So here's your level 3 try it for the day. Last week, Wednesday's low temperature was negative 4.5 degrees Fahrenheit. Thursday's low temperature was negative 1.2 degrees Fahrenheit. Friday's low temperature was negative 2.7 degrees Fahrenheit. And Saturday's low temperature was 0.5 degrees Fahrenheit. The average low temperature for the week was negative 1.5 degrees Fahrenheit. How many of these days had low temperatures less than the average low temperature for the week? Go ahead and try this on your own. Okay, so my average low temperature was negative 1.5. So I'm going to go ahead and draw a vertical number line here. We'll put 0 right here. And we'll put positive 1 here. Try to space these out correctly. Negative 1, negative 2, negative 3. Okay, it's not perfect. I tell you, I'm just not the best at drawing these. And the average temperature, it says in the middle of this line, was negative 1.5 degrees. So it's right about here. And this is average. And so we're looking for any number that's going to be less than that average. And we're looking to see how many days it will be. So I'm going to go in and plot those numbers. So Wednesday was negative 4.5. Guys, that doesn't even on my chart. So that would be down here. Okay, because this would be negative 4. So that would be clear down there. I didn't even draw the chart that long. Thursday's was negative 1.2. Well, remember, it was negative 1.5. So Thursday is going to be slightly above the average. Friday's low temperature is negative 2.7. So that would be about here. And then Saturday's was positive 0.5, so about up here. So here's my average. How many days are below average? I've got 1, 2. So there are 2 days with below average temperatures. Below average temps. All right, that's all of our notes for today. I hope you guys understand ordering and comparing rational numbers. It does take some practice. The more you practice, the better you'll get. That's that growth mindset. Have a great day of learning.